Hey, welcome back. So we saw multiple inheritance. We saw the trivial example of aquatic and ambulatory and penguin classes, where the penguin class inherited both from aquatic and ambulatory, two different classes. They both had a greet method, and the question was, why does it call one greet versus the other, and how is that order established? So I said that, if we put aquatic first, then we get the aquatic greet. If we put ambulatory first, then we get the ambulatory greet. But it's not always that simple. You might have multiple classes, and then aquatic might inherit from two other classes, and they might, also have greet, and ambulatory might inherit from another class that has greet, and the diagram might be crazy complex. So in a case like that, how do you know what the order will be that things will be run in? And the answer has to do with something called method resolution order, or MRO. Whenever you create a class, Python automatically sets a method resolution order, or MRO, for the class, which is basically just the order in which Python is going to look for methods on instances of that class. So it's like a hierarchy. I'm going to look here first on penguin, and then I'm going to look on aquatic, and then I'm going to look on, what was the other one? Ambulatory, and then I'll look on the base object class. So that would be the example, or one potential example from last video. And the way that Python actually establishes the order, the algorithm behind it, it has changed over the years. I believe it changed from Python 2 to 3. There's a shift. And on top of that, it is pretty complex. And there's entire blog posts that are very long devoted to dissecting the algorithm. This here is the documentation for 2.3. So not exactly what we want, but I just want to show you, if we scroll down, you can see it starts to get into a decent amount of math and also some ASCII art here. But it talks about the algorithm and how it works. We are not going to get into the nitty-gritty details of this. Instead, I'm going to show you 3 different ways just to access and see the MRO for a given class, so that if you're working with your own class or a class that someone else defined in an external module, or even a built-in thing, and you just want to know what the MRO is, you have 3 different things that you can use, 3 different ways to find out. So there is a Dunder MRO attribute that is built into classes. So you can call that on any class you define or any other class you come across. There's an MRO method that you just pass a class into. And then there's the built-in help function we've already seen. You pass in a class name. And this is the most ideal. I don't know. It's the one I like the best. It just gives you the most readable human format to see what's happening. So for example, using the penguin class with Dunder MRO, we get this little tuple back. If you do the MRO method, I believe you get a list. And then if we do help, it opens up this more readable thing that's better for us humans to look at. I assume that you are a human watching this. It's easier for us to read. Okay, example time. And before I dive into the details of this, I just want to say this is another thing that most Python courses I've seen. Actually, I haven't seen any course on Udemy that covers this, but this is not something you have to panic about if it does confuse you. But it's just kind of cool to know how it works. So I have a simple example with, 4 different classes, and there's the base A class, there's a B class that inherits from A, there's a C class that also inherits from A. So we sort of have this this shape going on. We have an A, and then we have B inheriting, and C inheriting as well. And then we have D, which inherits from both B and C. So this diagram is hideous. Let me clean it up. Okay, I did my best. It looks something like this. So you have the base class A, which then B and C both inherit from, and then D inherits from B and C as well. So it's not as simple as, just a linear thing where we have A, B, and then D that inherits from B. Instead, there's some ambiguity. And on top of that, so there's a method called do something that's defined in all 4 classes. And all that it does is print method defined in, and then the class that it's been defined in. So if I print, first I make a new instance of D, and then I print thing.doSomething, what do we expect to see? Just based off of our previous experience, it should call do something that's defined in the D class, which is this one here. Should say method defined in D. So let's check that. Run the file, and we get what we expected. Method defined in D. Okay, so now the trickier thing. I'm going to comment this one out, and if I just leave it like this, we'll actually get an error because Python is going to the class is empty and it's going to tell us it expects an indented block. So we can just add a pass for this empty class. So now, which version of do something is called? Because both B and C, both of them have do something defined. Which one is called? And to find out definitively, what we can do is use, I'm going to comment both of these out. What we can do is use MRO. So we can do a print D dot underscore double underscore MRO like this. That was the first method, and that will tell us, or it's actually not a method, but by method I mean first way of finding it out. So we get this, and you can see here, it goes from D, then to B, then to C, then to A, and then to the base object class. Our next option is to do D dot MRO method there. And this one just gives us a list, same order, so all of them should give us the same order, otherwise there'd be a big problem. And then finally, the one that I prefer is help D. And we've seen this before, it opens up this little menu thing. And up here you can see method resolution order, and it's just printed out in a nicer way for us to read. We don't have to see like a tuple that says class and all those brackets. We just see D, B, C, A, built-ins dot object. Okay? So this explains it best. DBCA. Hit Q to get out of there. Let's go back. I'll leave those three commented out. And if we go here again, so we decided it was, or we didn't decide, but we saw it was D, B, C, A, object. Comment that out just so we have that if you're looking at the notes. So now, if I run this, we get method defined in B, which makes sense. B was next after D, which we commented out. Okay, so we could comment out B, add a pass in there, and we should expect it to go where? To C next. And we get method defined in C, and then one more time, pass. We get method defined in A, which is this one. Okay? And if we did comment this out and put a pass here, what would we expect to find? Well, we'd get an error. It's going to look on D. There's nothing called do something in C and B and so on in A. And we'll look, I believe it'll look on the base object as well. And there's definitely nothing called do something. So we'll throw an error saying D has nothing called do something. I don't know what you want. And if we do run it, there we go. D object has no attribute do something. So lastly, what this means is that when we call super, let's say in D, inside of this method I refer to super, it's going to refer to whatever's next in line in that MRO, so B. And super on its own won't get us that far, but if we do super dot do something, and we try running this now, we should see D and then B, which is exactly what we get. So back in the previous video with the multiple inheritance example with penguin and ambulatory and aquatic, when we were calling super, it was using the first thing, well, it was penguin and then, I can't remember which order I had it in, but then ambulatory and then aquatic. So super inside of penguin was referring to the next thing in line. Same thing here. So I won't do the entire thing, but we could keep going up the chain here. Super dot do something. Just stop after this. Now we get DBC. And if we kept going, next up would be A. Alrighty, I'll leave this at that. MRO is very complex in how it's actually calculated, how Python sets it up and figures out the order things should be resolved in. But for us, there are these three different ways that we can find out the calculated MRO for a given class, and I prefer help. Okay, moving on.